This is Lesson 7.2, Arithmetic and Geometric Sequences. As a note, this lesson was recorded live in class during 2020. And arithmetic, now we spell it like arithmetic, but the way we say it in this context is arithmetic sequence. That's not really going to fit. An arithmetic sequence, so you spell it just like arithmetic, but arithmetic sequence is a sequence of numbers where each term after the first is found by adding the previous one by a constant number. You guys are very familiar with arithmetic sequences, like 2, 4, 6, 8, 10. That's an arithmetic sequence. What do you add every time? 2. And that's an arithmetic sequence, okay? All right, the number added to each consecutive term in arithmetic sequence is called the common difference. Common difference. Yes, question?
Would the Fibonacci sequence be an arithmetic?
The Fibonacci sequence is not an arithmetic sequence because if you look at what the Fibonacci sequence is, it's 1, 1, 2, 3, 5, 8, 13. And so you're adding not the same thing every time, you're adding a different thing every time. So there is a pattern, but it's not arithmetic in nature, okay? So just because there's a pattern, that doesn't make it an arithmetic sequence. It can be another kind of sequence. It's just not that kind. Okay? Question?
Is a linear equation the same thing as an arithmetic?
Oh my gosh, that is a brilliant question. The question was, is a linear equation an example of an arithmetic sequence? Yes, it is, because you're adding a constant rate of change. You're adding 2, you're adding 2, you're adding 2. Yes, exactly. Very good. Okay, well, and we'll talk about that more as we go. Okay? All right, continuing on. A geometric sequence. Sorry, I should have left more room here. Geometric sequence. Geometric is a sequence of numbers where each term after the first is found by multiplying the previous term by a constant number. So you multiply by 2, you multiply by 2, you multiply by 2. So the sequence of 2, 4, 8, 16, 32, 64 would be an example of a geometric sequence. What does that sound like that we've done? Exponential, yes. So let's put that, because since you guys said that. So this is an example of a linear, and this example would be a geometric, or no, exponential, sorry. Exponential. So an exponential is an example because you're having this number that you're multiplying by every time, okay? So the number that you multiply in a geometric sequence is called the constant ratio. Constant ratio. Okay, a sequence is a set of numbers in a specific order, and each number is called a term. So an example like a Fibonacci sequence, that's a sequence. It has a particular pattern. You're doing something every time there's an order to it. You can't just throw out random numbers. That's not a sequence. So if you can identify a pattern, that is a sequence, but it's not necessarily an arithmetic or a geometric sequence. If you guys remember back when we were identifying linear and exponential, just because there was a pattern didn't make it linear or exponential. It might have been something else, okay? So, questions? Okay, that's our vocabulary. Let's take a look at the first sequence. So it says, consider the sequence, and I'm sorry I can't zoom in on this, but consider the sequence 4, 7, 10, 13, 16, ... Okay? So the number blank is the first term. What is the first term in this sequence? 4. Let's say it out loud. 4. Okay. The symbol that we use to represent the first number in the sequence is A sub 1. And so it's an A with a little 1 as a subscript. And we say A sub 1 for that. Not A1. It's not steak sauce. Okay? A sub 1 is what that is called. And that's what we use to represent the first term a lot. Now there's 2 different ways of how to represent arithmetic and geometric sequences. I'm going to focus on this one way, but I'll kind of let you in on another way, just FYI, so you'll have seen that before. But what we would write in number 8, we would say A sub 1 is equal to 4. What's A sub 2?
7.
What's A sub 3? Boy, you guys are smart. There you go. Okay. All right. So, and we can do a sub, 15 or 27, and you just have to figure out what that is. So if I said a sub 100, you would have to figure out what the 100th term is. Now, the good news is we're going to find a quick way to do that. Okay? All right, let's go to the next one. Consider this sequence. Didn't we just do that? Oh, there was more questions. I was supposed to just add that. Sorry. Okay. Is there a common difference or a constant ratio? Common difference. You guys can just circle that. Common difference. What is the common difference? 3. All right, now here's one thing that we got to make sure that we understand. It is the number that we are adding every time. So what if it went down? We would be adding a negative, okay? So when you say what the common difference is, you're going to say D equals, and it's always what you're adding. So that means that if your sequence is going down, you would have to say you're adding a negative number. If you're subtracting 3, and you say the common difference is 3, that's wrong. Okay, you have to say what you're adding. Okay, is it arithmetic or geometric? Arithmetic, and we know that because we're adding every time. And I think I cut that number off. What does that say? A sub what? 7. That's what I thought. What's A sub 7? Can you guys figure it out? What is it? 21. How did you get that?
22.
Oh, 22? We added, so we added 3 and added 3, right? Okay, there we go. Any questions? Okay, let's go to the next one. So now we have a new sequence. 6, 1.2, 0.24, 0.048, and so on. Okay, so there's a couple of questions, and we kind of have to ask them kind of in conjunction with each other. Is there a common difference or a constant ratio? So basically I'm asking, are we adding every time or multiplying every time? Or neither one, maybe. What do you think? Kimberly? We are multiplying. Okay, so we would say constant ratio. Now I'm not asking you yet what it is, but I'm going to ask you in the next question, what is it? So this is kind of a harder question. Let me show you a way to figure this out, because sometimes it's really easy to see, and other times it's not very easy to see. So if you have this, if we say 6 times something is equal to 1.2, you guys, that's what we're trying to figure out. 6 times what? Well, that's just a one-step equation. You can just solve it. So solve for x. 1.2 divided by 6. What is it? McKinley? 0.2? So 0.2, that's my common difference. I mean, my constant ratio. Sorry, constant ratio. And you can do that to figure out what the constant ratio is pretty easily. Otherwise, you can sit here and guess and check numbers and say, well, I think it's going down by half. Well, what is it doing? Like, what are you doing? Okay? You have to make sure that whatever you say, 6 times 0.2, that has to be 1.2. Is that true? Does that work? And 1.2 times 0.2, it has to be 0.24. You have to make sure it keeps working. We talked about this back when we did exponentials. You have to make sure that pattern still exists. Question?
Could you just say like 1.2 over 6 and then 0.24 over 1.2?
Yeah, and understanding that that's the pattern, that you're just saying like 1.2 divided by 6 is going to tell me what you have to multiply 6 by to get 1.2. It's kind of like, in elementary school when you did fact families. Like 2 times 4 is 8, so 8 divided by 4 is 2, that kind of thing. Just understanding how they work together. And the better number since you have, the easier that becomes. Okay? But if you're ever in a place where you are not sure what the constant ratio is, you can just say 6 times what gives me the next term. And you can solve it. And you can find out what that number is. Okay? So that's what you do if you're stuck, if you can't see it. Yes?
If the constant ratio was negative, wouldn't that make it?
That's a good question. So what if the constant ratio was negative? Let's just do an example and see what would happen. Okay, so let's say that we are going to start with, 2. And let's multiply by negative 2. So what if I said the constant ratio was 2? So I'm going to start with 2 and I'm going to multiply by negative 2, so I get negative 4. Okay, then I'm going to multiply by negative 2 and I get what?
8.
And then I multiply by negative 2. Okay, now if I graph this, it's going to be doing that up and down thing. Remember we talked about that back when we did exponentials? So a geometric sequence, we probably should have put this earlier, but in the geometric sequence, the ratio is going to have to be greater than 0. It can't be 0 because then it would just be 0 the whole time. And it can't be a negative number because then it does that up and down thing. It's not an arithmetic or a geometric sequence. Okay, so it still follows the pattern where you multiply by the same thing, but the graph of it won't look the same. Okay? So we will maybe see that a little bit when we move on. Okay? I mean, not a lot, but a little bit. Okay, so is this sequence in arithmetic or geometric? What did we decide? Geometric. Okay, can you guys answer the following questions? A sub 0. Ooh, what is that? Elizabeth?
I think it's A.
You think it's what?
A.
You think it's A? What is A? Just so like you would just write A?
That's well, because A sub 1 is the first term in the sequence. The reason I think it's A is because on the thing back there they say y equals y sub 0.
Okay, let's go. Let's see what everybody else has. Hey, Dale, what do you think?
30.
How do you know that?
Because 30 times 0.2 is 6.
So, would you say that you're going backwards?
Yes.
Like you were finding the term that came before the first one? Is that what you're doing?
Yeah.
Lucy, what were you going to say?
I was going to
How did you get 30?
because I did, same thing.
So you just kind of used the ratio but going backwards?
Kind of, yeah.
Okay, yeah.
The
What
way
did,
that I did it is instead of doing like the way that I did it earlier, 1.2 over 6, I just did 6 over 1.2. And that
so you go
gave
the
me
other way. Okay, so the thing with a sub 0, that's what it's kind of a new thing, and it's called the 0th term. I bet you didn't know that was even a word. 0th term. And it's the term that comes before the first term. Okay, so in this case, yeah, it is 30. And then the first term is the first one that's listed there, and that would be 6. And we'll talk a lot more about the 0th term coming up. Okay, that's going to be a really important piece. We'll talk about that more. What do you think a sub 4 minus 1 is? Donna?
I think it's 0.24.
Okay, and why did you think that it was 0.24?
Because 4 minus 1 is 3, so I just kind of assumed that it's talking about A.
4 minus 1 is 3, so you think that it's talking about a sub 3. Okay, that's actually correct. Okay, yeah, that's right. So 0.24. Did you have something to add to that, Preston?
No, I just think they're different, but I got
Oh, okay. All right, so what do you think a sub 3 plus 2 is? Yes.
0.0096.
Good. 0096. Because that's a sub 5. Okay? So we're not going to see like subscripts like 3 plus 2 a lot, but we're going to see all kinds of subscripts in our terms, and it's just talking about this term versus that term or this term. Okay? So we'll see a lot of those subscripts as we go on. Okay, write the sequence as ordered pairs. So this sequence, 4, 7, 10, 13, 16, how do we write that as ordered pairs? Well, okay, you got an idea, Dale?
1, 4, 2, 7, 3, 10, 4, 15, 5.
Yeah, since 4 is the first term, that's going to be first term is 4, second term is 7, third term is 10, fourth term is 13, and fifth term is 16, and you don't have to write beyond that, just write ... Okay? So those can be written as ordered pairs. You can also write this sequence in a table. So we've got our inputs in this top table, and that's 0, 1, 2, 3, 4, 5. What do you think those 0, 1, 2, 3, 4, 5 stands for? What do you think?
It's like sub 1. It's the top row is X and the bottom row is 1.
Right. So like you were saying, like a sub 1 and a sub 2. Yeah, that's what that is. Okay? So you guys can easily fill in this part. Can you fill in that one? Can you fill in a sub 0? What is it?
1.
How did you know that?
Because the first number is 4 and 4 minus 3 equals 1.
So instead of adding 3, like we do every time, if I'm going to go backwards, I will subtract 3. Does that make sense? Any questions about that? So I'm going to have 1, 4, 7, 10, 13, and 16. Okay? All right, let's go to the next thing. Okay, you're going to have a lot of questions like this, and I'm going to give you a sequence, and you're going to have this set of directions for them, okay? So the first thing you're going to do is determine, is it arithmetic, geometric, or neither? If it is neither, you get to skip the rest of the question, okay? But you better make sure that it's really neither before you skip the rest of it. So if it is arithmetic, find the common difference. If it's geometric, find the constant ratio. And then I want you to find a sub 0 and a sub 1. Okay, so The sequence is 6, 9, 13.5, and 20.25. So first of all, what kind of sequence is that? So I need somebody to tell me and how you figured it out. So who wants to be that person? I'll give you a second. Okay. Jessica, what do you think?
So I think it's geometric.
Okay, first off, how many of you guys agree with her that it's geometric? Okay, pretty much everybody. Okay, so Jessica, how did you figure that out?
Well, I divided 9 by 6 and I got 1.5, and then I divided 13.5 by 9 and
So you made sure that that works every time.
yeah.
So 13.5 divided by 9, and that's equal to 1.5, right? Okay, did you guys all do like a similar type thing to figure that out? One thing you want to make sure that it really continues to work and it doesn't like surprise you there at the end and does something different, okay? Because like with say the Fibonacci sequence, if you just look like the first, one and you're like, oh, I just add 1, that's not how it works, okay? So you have to be careful that whatever you're saying works. Okay, so we're going to say that the constant ratio is 1.5. Now, you are allowed decimals here, okay? Especially because what do we see in the problem? We see decimals. Okay. A sub 0. So now we have to back it up and we have to find out what was it before it was 6. So who can tell me? Yeah. 4. Good. Because if we do, you could do a couple ways. You can say x times 1.5 is equal to 6. You can say 6 divided by 1.5 because we're going backwards, which is actually all the same math anyway. And then a sub 1 is going to be the first term in the sequence. Okay? All right, let's go to the next problem. Okay, I just repeated the directions up here, but there's the sequence for you. You guys go ahead and figure out what that is. Okay, Tommy, what do you think?
Neither.
Why do you think that?
Well, it seems to go at a rate of what's it called. Well, it seems to add 4 every time for the first 2 or 3, and then it just jumps up to 8.
Oh, did you guys catch that?
Yeah.
Oh, good, because I was trying to trick you on that one. So if you just look at the first couple, it appears arithmetic, right? Add 4, and then, oh, hey, look at this. Add 8. Good catch on that. Okay, so yeah, this one is going to be neither. And so we'll write neither there. And because it's neither, you can skip the rest of the question. Okay? All right. Let's go to the next one. Go ahead and figure that one out. Okay, did anybody have an idea of which one it was going to be? And can you explain like why you thought it might be that? Okay, let me see if I get Michael. What do you think?
I thought it was gonna be. At first, I thought it was gonna be geometric because it looked like it was a whole bunch of decimals. But then when I looked at it closer, I saw that it added 1.3 every time, and so then I thought it was arithmetic.
So how many of you guys got thrown by the decimals? Because, usually when we've seen decimals, a lot of that time it's been like exponential equations and things like that. Did any of you look at the numbers and notice that they're all fairly close to like the same length or width apart? Like, yeah, you notice that? So that's kind of like a clue that I would key into is like they don't look like they're getting further and further apart or closer and closer together. They look like they're kind of staying the same. So then what I would do is then I would check and see like what's the distance. And so you find out that this is 1.3 and this is 1.3 and that's 1.3. So I think we're ready to say what this is. So what kind of sequence is this? Arithmetic. Okay. And we're going to have a common difference or constant ratio? Difference. Okay, remember the ratio, that's going to be when you multiply. Okay? The common difference, that's like a subtraction thing, so you can think add, subtract. Ratio is like a division thing, so you can think multiply, divide. So that's why the one goes with the other. So what is our common difference? Michael said it. You want to say what it is again?
It's
1.3. Okay, good. All right, a sub 0. Instead of adding 1.3, take away 1.3 to go backwards, and we get what? 7. And a sub 1 is 8.3. Okay? All right, one more I think like this. So let's see what we've got here. All right, what do you think, Austin?
I want to say neither, even though I think
Okay, so there's a pattern, right? Did everybody see the pattern? Okay, so it just kind of depends on, are we going to consider, like, if we multiply by a negative number, is that going to be a geometric sequence or an arithmetic sequence? So earlier, like with exponentials, that multiplication rate, that can't be less than 0. And so I think we're just going to hold to that. Okay, so if we say that r is going to be greater than 0, so in this case, then we would say neither. However, I will accept geometric because it does follow the pattern that you're multiplying by the same thing every time. So we can actually go either way on that. I'll let you know before the test what I decide. Okay, so geometric, and we would say, and I'm going to put in parentheses neither, okay, because of that. I want to make sure that we're clear that, it is multiplying by something every time. So I'll probably look that up and see if I can find some better authorities on that as far as what that is considered. So r is equal, if we're multiplying by something, what are we multiplying by every time? What is it? Negative 3. Okay. All right, so a sub 0, what would I do to get to a sub 0? What am I going to do? Mallory, what do you think I'm going to do? So what math? Divide by negative 3, right? So negative 2, and a sub 1 is 6. Okay? All right, let's go to the next thing. We'll skip this part. Right is a set of ordered pairs. So we already talked about doing that. Let's skip that one. Okay, this one, we're going to skip most of this too because it's just kind of reviewing the vocabulary. So we won't worry about that. You can probably quickly write it in anyway. But let's go to 29. So 29, a sub 0 represents the term before a sub 1. So the term before a sub 1 is a sub 0. Okay, yes?
Isn't it also the y-intercept?
Ooh, you guys are so quick to catch on this stuff. It's also the y-intercept, and that's why it's important. That's why we care about that a sub 0, because it is the y-intercept. Okay? And so we'll talk more about that as we move on. Okay, if a function is linear, the equation is written in slope-intercept form. What is slope-intercept form? Write it down, you guys. What is slope-intercept form? We've done that a lot. Okay, if a function is exponential, it's written in exponential general form. What is that? Do you remember that one? That was a little bit more recent. Who knows it? Ooh, Elizabeth?
Y equals a, b in parentheses, to the x power.
Yeah. Technically, you don't have to have parentheses on that since b is the only thing in there, but it's good practice to have that. Okay, so we're going to go into that. So, let's do this one real quick, and it seems like it's the same, but we're going to kind of take it a little bit different direction. So, determine if it's arithmetic, geometric, or neither. So, which one do you think? Jordan?
Arithmetic.
Why do you think that?
Because it's going down 3 every time.
Down 3 every time. So, we would say that the common difference is d equals negative 3. Because it's going down, you have to say negative 3. Okay, now write the ordered pairs. So, we're going to start with 1, 5, and 2, 2. 3, negative 1, 4, negative 4, and 5, negative 7. We could also throw in, depending on what we're doing, we could also throw in 0 what? 8. Okay, Jessica, what were you going to say?
I was just going to ask if you wanted us to write the 0.
Oh, okay, yeah. You don't have to on this, but it's something that we're going to want to know later, so it's not a bad idea to write that in there, but you don't have to because it's not listed, so you don't have to write that. It's kind of like you don't have to write anything beyond the 5th term because it's not listed there. So we could figure out what the 6th term is, but we don't have to list them all. Okay. The next thing we're going to do is we're going to graph this set of ordered pairs. So I went to a different screen here, but this set of ordered pairs, you guys, I want you to graph those ordered pairs right here on this graph. Okay, right there. Now, if we went ahead and did the 0, 8, like we were talking about a second ago, we would have that. Now, there's a couple differences when we graph a sequence versus when we graph a line. The line, we're going to connect the dots, but the sequence, we're not going to connect the dots. Can anybody think of why we would not connect the dots? Preston, why?
Because, like, if you were in between 2, 2, and 3, negative 1, that doesn't mean that 2.5, there's no in between.
You can't have like a 2.5 term.
Yeah.
Like it's either the second term or the third term. There's nothing in between. And so by not connecting the dots, we're saying like it's this one and then it goes to this one. There's nothing in between there. Okay? Oh, thanks. Can you set it down there?
Yeah.
Oh, and can you take... Okay. So we don't want to connect these dots. All right, but this is the graph of the sequence. Now, if we're representing the sequence, the equation that represents the sequence, though, we can write the equation that represents the sequence. So that's where we're going to go and look at these other questions. So E, is the sequence representative of linear or exponential data? That represents linear data, okay? And you can see how it's going in a line. Like if you were going to connect it, it would be a line. What is the slope or rate? So since we've decided it was D, what is the slope? -3. So D equals -3, and the slope is -3. So the common difference is the slope. Okay? So whatever you decide the common difference is, that is your slope. Okay? Notice how it goes down 3 over 1, down 3 over 1 every single time. What is the y-intercept? Yeah. It says slope, so you can just write this. Okay? No, write m equals -3. Okay. Oh, you are going to survive. Okay. What is the y-intercept? So we're going to write b equals what? 8. Okay, and that's where finding that 0th term comes in because you're going to need that anyway. Okay, how can you tell the slope or the rate from the sequence without graphing it? So this is kind of the connection there. So how could I tell the slope if I didn't make a graph? How?
Like delta y over delta x?
Yeah, if I looked at the ordered pairs, I could do that. Is there something else that would even be faster, like if I wasn't going to graph it?
The common difference.
Yeah, the common difference, which is actually what we're doing when we do that, we're finding the change in the change in the y's is what we're doing. But the common difference for a linear or the constant ratio is actually going to give us our slope or our rate, depending on which one we're talking about. Okay, so once you've determined that, like we've got the slope. Okay, let's go to the next question. How can you find the y-intercept or initial value from the sequence without graphing it? So if I wouldn't have done this and like continued up here, how would I get that? Okay, Preston.
Just do a sub 0.
Yep, a sub 0. All right, write the function or equation using f of x. So instead of saying y equals mx plus b, we're going to say f of x is equal to, what's the equation for this sequence? Yes?
-3x plus 8.
Perfect. Okay, so that equation represents the sequence. Okay, obviously our inputs could only be positive integers, like the first term, the second term, the third term, because we can't put in like 1.5 because that wouldn't make any sense. But this is a sequence. Okay, let's go to the next one. Okay, so here is another sequence. So first thing is I want you to figure out a sub 1, a sub 5 minus 1, a sub 0. Can you guys also figure out what comes next? Okay, go ahead and answer the questions here through H. Okay, so what is the next term that's going to be in this sequence? Who's got that? Next term. Austin.
128.80.
128. What?
122.
122.80. That's right.
Can you say that in like...
Yeah, 12,280.
Okay. That's what I thought you meant, but I just had to be sure that that's really what you were saying. Okay. All right, so a sub 1, did everybody put 12 for that? A sub 5 minus 1 is? Okay. A sub 0 is? 3. And we get that by, instead of, what were we doing to go forward? Multiply by 4. So we divide by 4. Okay, so is it arithmetic, geometric, or neither? Geometric. What is the y-intercept? 3. Okay, it goes back to a sub 0. Okay, can you guys write the equation? H of x is equal to what, McKinley?
H of x is equal to 3 parentheses 4 to the power of x.
Perfect, right. Okay, find h of 6 and check to see if it fits the pattern. So if we do h of 6, that means we're going to do 3 times 4 to the 6th power. So put that in your calculator. Does it give us the correct 6th term?
Yes.
Great. Let's go back to number 34. Okay, and let's graph those points that are on that set of ordered pairs. Okay, so we're going to start with, you could do the y-intercept was 12. There we go. And then it goes to 1, 6. Could you guys write the equation for this? Do you remember how to write an equation for this? This is exponential what? Decay. Can you write an equation? Now again, we're not going to connect those dots because you can't have like a 1.5 term or a 1.7 term. There's nothing in between the first and the second term. So we're not going to connect it. But the equation that we come up with, that is going to describe it. Okay, so who can tell me what my equation is going to be for number 34? Yes.
It says D.
Oh, d of x? Oh, sorry.
So
D.
D of x equals 12 parentheses 0.5 or 1 minus 0.5.
Okay.
And then parentheses 2dx power.
Very good. So what he was saying is in there you could have 1 minus 0.5. That's fine too. Okay. All right, great job. Okay, so let's go to the next question. So 35, just kind of again reviewing the vocabulary, an arithmetic sequence is representative of linear or exponential. You can just circle. What's an arithmetic sequence representative of? Linear. A geometric sequence is representative of exponential. The first term is represented by what? A sub 1. If a sequence increases or decreases by a constant number, then it is what? That one's arithmetic. Okay, if it's increasing or decreasing by a constant number, so like add 3, add 3, add 3. The common difference is represented by what letter? D. The constant ratio is represented by what letter? R. And the y-intercept is represented by A sub 0. B is when we're writing it in slope-intercept form, but when we're talking about sequences, we're going to be saying A sub 0.